designing a model bridge to carry a maximum load using as little materials as possible. For middle school, you are allowed to use a maximum of 200 popsicle sticks, and this includes partial cut sticks. For example, here, that's not a whole popsicle stick, but that counts as one full stick. For high school, we'll use 1/4 inch by 1/4 inch balsa wood sticks. There's no maximum, but about 10 3-feet sticks is usually sufficient. The bridges must be labeled with team members' full name, grade, school, and MESA Center. Otherwise, a 10% penalty will be assessed. The bridge must also be the original work of the students and meet specification requirements, which we will go over shortly. Materials. Pacific Mesa will provide the following on Mesa Day: a structure tester to test the bridges. This is one picture of it here, but I have another one later on so you can see a full photo of what that looks like. And then for middle school, we'll also supply a drill for drilling a hole into the center of the bridge if necessary. The bridges do need to have an opening in the center of the bridge for the testing apparatus to go through. So as you see here, there's a threaded metal rod that goes right through the middle of the bridge. So if you don't have somewhere for that rod to go through, we do have to drill a hole, and here's an example of that. So I would suggest leaving a space there so that we don't have to drill your bridge and mess with the structural integrity of it. The only materials allowed are the following: water-soluble Emmer's white glue, sandpaper. For middle school, a max of 200 popsicle sticks, and for high school, 1/4 inch by 1/4 inch balsa wood sticks. No kits are allowed, and no materials such as paint, varnish, hairspray, clear coat, or anything of that sort may be applied to the bridge. Bridge specs for middle school. No more than 50 of the stick can be glued, so some examples of that are here. This is okay because 50% of the stick is still unglued right here, if you can see my little laser pointer. This is not okay because more than 50% of this stick right here is glued. So you can see that it's completely glued on one side of the stick, and then there's an additional 4 members here that are also glued. So that gives about 75% of the stick that's glued. Also, the glue must only be used at joints and mustn't be used on the surface of the roadway. So in this case, you could see a lot of glue on the surface of the roadway there. If this happens, sometimes that will accidentally happen. The glue might seep through, or maybe you're using wax paper and it gets stuck to the bridge. What you can do is take some sandpaper and sand that off. So it should come right off when you do that. And you might have to sand for a little bit, but that's just one way that you can try and get rid of that excess glue. The bridge must also have a clear and unobstructed roadway, at least 3.5 inches wide. It may not have a roof, covering, or anything obstructing the test plate that will be placed on top of the bridge. I-beams are illegal. An example of that is right here. So that's two popsicle sticks with one in the middle, basically in the shape of an eye. And T-sections may be used only on the roadway. And this is what a T-section looks like here. It's basically similar to an I-beam, just missing that bottom piece. Bridge dimensions for middle school. These are also in the rules, but the horizontal length can have a maximum of 17 inches and a minimum of 15 inches. The maximum width is 5 inches, but must at least be 4 inches at every point. The maximum height can be 7 inches, the maximum depth 3.5 inches, the minimum width at every point 4 inches, and the minimum width of the roadway 3.5 inches. So we'll get into that a little in more detail here. So the height, the roadway does not need to be the top of the bridge. In this case, the roadway is the top, but in this case, the roadway is here on the bottom. So you can have it anywhere on the bridge. The height of the bridge is the total height. So from the very bottom of the bridge to the very top of it. And the maximum depth below the roadway can be no more than 3.5 inches. So this right here is the depth below the roadway. In this case, the roadway is the very bottom, so the depth for this would be 0. The minimum width at every point is 4 inches, and what that means is that it cannot be lower than 4 inches. So the size of one popsicle stick is 4.5 inches long. So as long as you're using a whole popsicle stick as your width, then you'll be good. But if you do cut the popsicle sticks, you want to make sure that they're no smaller than 4 inches. The only part of the bridge that can be smaller than that is the roadway. So you can actually have the roadway be less than that 4 inches, but that's the only part that can be that way. Bridge specs for high school. The joints must be at or within 1/4 inch of the end of at least one of the sticks. No part of a stick may be glued to another stick except at the joint of the sticks. So an example of that is here. This is considered the joint of the stick right there. So that would be okay because you're within 1/4 inch of the end. So all of these are examples that are acceptable. And these are also located in the rules. So in this case down here, the joints that are circled here are definitely further away than 1/4 inch. So these would not be okay. Additionally, no glue may extend beyond 3 millimeters of any joint. What that means, let's say we're looking at this joint here. The green area is within the 3 millimeters of the joint, but if you were gluing, say, over here and there's no joint within 3 millimeters, that wouldn't be okay. And again, also with high school, you can use sandpaper to sand off any excess glue. Any members that are joined at an angle must be 30 degrees or more. So there's an example of that here. So you see an angle right here. This is the green is 30 degrees, and you can see that the angle is more than that compared to this angle here, where the red triangle is 30 degrees, and you can see that the angle is a lot less than that. Members may be carved, notched, or cut anywhere along the length. What a notch looks like is something like this, where you essentially cut into the balsa wood and connect it to another piece of balsa wood. Pins and gussets are not allowed, and the top of the bridge must support a 10 centimeter by 10 centimeter plate. Bridge dimensions for high school. This is also in the rules under the rubric section. So you can see here the different sides of the bridge. We have the height, the width, the clearance, the span, and the length of the bridge. The maximum length is 40 centimeters. The maximum width is 10 centimeters. The maximum height is 21 centimeters. The maximum or the minimum clearance is 10 centimeters. The minimum span is 25 centimeters, and the maximum weight is 95 grams. For the competition itself, you can work in teams of 1 to 3 students. So that means that you are able to work by yourself this year if you would like to. Specifications will be checked prior to the competition. Teams will be called in random order and have to be present or they will forfeit their trial. Bridges will be tested for load capacity. Middle school will use a 3.5 inch by 3.5 inch test plate, which will be placed on the roadway. In this case up here, this is the bridge tester, and this, you can't really see it, it's a little light. This is where the plate would sit. It would sit on the highest point there. In this case, the roadway is at the bottom, so this bridge actually would have been disqualified because the roadway is not somewhere where the plate can be placed. For high school, 10 centimeter by 10 centimeter test plate will be placed on top of the bridge. So again, this test plate right here would be a little bit different in size and would set on top of the bridge for high school. The load will be applied to the bridge until the maximum load is reached. The measured load will stop increasing, and that's the load that will be recorded. So I am going to have a video up on the website soon that shows this little piece of the bridge tester right here, it lists out the load, and this part right here is where we twist, and it applies that load onto the bridge. And then as soon as the maximum load, a number stops increasing, that is the number that we will take as your maximum load. So it doesn't necessarily mean that we're going to completely break the bridge. It might stop increasing after the first crack, or it might stop increasing after the bridge is completely broken. It depends. It's different for every bridge. Disqualified bridges may not place, but they can be tested if we do have time at the end of each session. Oh, actually, I forgot that I included the video already. So let's take a look at that. So as you can see here, this is the peak load. So once that stops increasing, you can even hear the bridge cracking right now. Okay. So you see that I continue to turn and turn and turn, and it's just not going up anymore. So that means that the maximum load has already been applied. Okay, scoring and awards. So strength to weight ratio will be used to determine the final team score. The ratio is calculated by multiplying the maximum load by 454 grams per pound, which is just a conversion factor, and then dividing that product by the bridge weight. So an example of that would be a max load of 220 pounds, a bridge weight of 50 grams. Calculating the ratio, we come to a ratio of 1,997.6. The highest ratio will be the winner, and medals will be given to the top 3 teams for each grade level. So that'll be 6th grade, 7th and 8th grade, 9th and 10th grade, and 11th and 12th grade. And we'll open it up for questions. This is just a very short presentation, just kind of running through everything real quickly. We will have a full presentation of all of the rules and specifications that will be up on the website where I showed you. And then she's actually just finishing that up. And then once she finishes it, I will post it onto the website and we'll let you know.
We did get one question in the chat. A couple of questions coming in now. Can we use hot glue instead of Elmer's glue?
Unfortunately, no. It's only Elmer's glue that is allowed.
All right. Yes, and Elmer's glue does take a while to dry, so you have to get a little creative about doing multiple things at once while you're building your bridge. One of the things we have on the list is like binder clips. Some students, especially those of you who've done this before, know that like that clip kind of helps to keep things together while the Elmer's glue is drying. So that's one thing you can use, but you can get creative about using other things too. Another question, will materials be provided for bridge?
Yes, so there is a deadline for you to provide what materials you need. And there's a form on our website that has that a space where you can select your materials, and we'll prepare those for you individually or for your team. And you can actually choose what you need. So if you need, 200 popsicle sticks and some Elmer's glue, we will provide those for you.
Yeah, so for all of the projects that have in-person pieces, those materials will be provided for you, and your advisors and your liaisons will help sort of direct you to how you guys are collecting your material lists to give to us before October 2nd. But definitely start thinking about what you want. Another question, what is the diameter of the spike that would go through the bridge?
So I'm actually going to measure that since the bridge tester is right behind me. It is 1 centimeter in diameter.
All right, 1 centimeter in diameter. And what is the size of the base that the bridge will be sitting on when the bridge is tested?
So so it's actually, oh, it's kind of heavy. Let me see if I can let me just bring my computer over here. So it is actually 2 supports. Can you, it's really weird to do this.
Yeah, you can see it pretty well, actually, Rose.
Okay, so there's 2 supports, and for each middle school and high school, the distance of those 2 supports is different. But are you asking the thickness of this or the distance? I'm not sure who asked the question.
That was from Alexi.
So the thickness of these supports, I think it's in centimeters.
The thickness, he wants to know the thickness.
It's 4.5 centimeters.
All right, and then one question that was answered, yes, all names should go on your bridge for if you're doing it with a partner or with a group of 3, everybody's name should go on the bridge. And then the next one, if we do with a partner, does only one person do the project or you have to do 2 or more for each partner?
If you're in a team, you will all just do 1 bridge. So it's not 1 bridge per person in the team, it's 1 bridge per team. So whether you have a team of 1 or a team of 3, it's just 1 bridge for each team.
Great. All right, any more questions? Does our partner need to be in MESA? So it would be, if you're working with a partner that's in 6th through 8th grade, we would like them to be enrolled in MESA. But if you have a younger sibling, for example, that you're working with that just wants to help you out and is going to be a future MESA student, that's definitely okay. We encourage you to do that together. But you won't only put your own name on the thing if you were working with like a little cousin or a sibling or something. All the stuff on the presentation will be on the MESA link. So yes, everything is going to be, everything that we're talking about, all of the rules and our videos are all going to be on the website. And Nimran just wrote the website address in the chat. It's www.pacific-mesa.com.
Yes. So everything you need is there. The rules, there'll be videos going over the rules also, and any tips and tricks that we can provide, as well as any useful resources that we think might help you. We'll post that up there on the website.
And last really great question I see here, do I go to school for the supplies? And that's going to depend on your school. So your advisor will be talking to you guys about how you guys are organizing material pickups. Some of you will come to Pacific, some of you will go to your school site. That just depends on each school. It's going to be individual for that. All right.
And if you are not part of a school advisor program, or if you don't have an advisor, then we do have material pickups that we'll have later, and we'll make sure to notify you about that.
So on that note, I am going to introduce Nimran. She is a longtime MESA Machine alum, and she's the president of McNair MESA last year, and she is our curriculum assistant this year. So I will let her take it away.
Great, thank you, Elena. Yes, my name is Nimran. As Elena said, I've done MESA Machine since it was a project, like when it started. So I've done it for 4 years. Let me share my screen and then we will start the party. So do you guys see my screen?
Yes.
Okay, awesome. So let's see. Okay, so we have MESA Machine. And so before, actually, let's go into our picture. Let's hit present. Okay, so this is my MESA Machine from last year, and as you can see, there's a lot of color, there's a lot of things going on, And that's actually what all of your MESA machines are going to end up looking like. Maybe less color though. We did go extra with the painting. But I affectionately named all of mine. So mine last year was named Dia. And so you can kind of see on the top here that we have like a ramp, and there's a series of ramps. It's a little hard to see in this picture, but following the arrows, we're going down. We see a seesaw, a pulley, more ramps, and a catapult, and even a balloon over there. So there's going to be a lot of action. So with that said, let's go into what is a MESA machine. So a MESA machine is pretty much taking a very simple action. So in this case, the action would be just wiping your mouth with a napkin. Taking that action and complicating it with a series of other actions. So as you can see in this picture, his first action, which is labeled A, he picks up a spoon, and then there's a series of actions, B, C, D, E. There's a bird in there. Just to wipe his mouth with a napkin, we've even involved a bird and a clock and the cleaver over, not the cleaver, but the sickle over there. So that's the beauty of this project, that there are going to be several different ways that you can make it happen. So this year, we're unfortunately not working with napkins or launching a ball, as was in my presentation, in my picture. But our objective this year, I've listed it out in 4 boxes. So the first thing that you're going to want to do is make sure that you have 5 to 10 actions for middle schoolers or 6 to 12 actions for high schoolers. And each of these actions have to be sequential or dependent on each other. So as I put cause and effect, so none of the actions can be independent. You can't just have, for example, a ball roll and hit a button which turns on lights or just launches something randomly. That will not count as an action. That launching sequence or even that light sequence, that has to go into the next action. Then going into what are actions and what the actions need to include. So actions are, they're just things that happen in there. So like a ball rolling, something launching, a pulley being triggered, all those things are actions. And so this year we have 2 categories. If you were in MESA Machine previously, you know that the categories are known as energies, and we had more last year, but this year they've simplified it to 2 types of categories. So we have simple machines, which are the inclined plane, lever, pulley, wheel and axle, screw, and wedge. And we have electronics, so DC motors, Arduino, sensors, etc. You need to make sure that each of your actions fall under one of those 2 categories. And I will clarify a little more on what certain actions that do or do not qualify. So our third objective, which kind of really is important to consider while you're doing the first objective, is that the goal of our MESA machine is to design a wind-powered vehicle and to propel it with like an action that generates wind. And so the final action is going to be some kind of fan, most likely a fan, to be entirely honest, that will push a wind-powered vehicle. So if you've done balloon-powered cars in 8th grade, I know that's what I did, or you'll see a picture of an example in one of the later slides. And Rose also has a video of a paper plate or a foam plate vehicle. So just those types of things, something light, most likely, that will go a certain distance, and we'll talk into what the main competition is. But that's the goal of your MESA machine this year. You're going to want to create wind in some way with the last action, and you're going to push a vehicle a certain amount of distance. And this last objective is extremely important because with all the chaos that comes in this project, and with all of the rules and intricacies and lack of intricacies, you really need to read those rules, follow the instructions, understand what's going on. And one of the biggest things, not only for this competition, but for even bridges too, because a lot of people tend to forget the labeling till last minute. You really want to make sure that you've labeled your machine with all the things that they have said in the rules. I think it's number 1 on all the rules. You're going to want to look at the safety guidelines, the judging specifics, and the size restrictions, because all of these things, if you are not following them, you can be disqualified. And we don't want that to happen on competition day. So elaborating more on actions, all MESA machines have to be initiated with the pull of a string. In Previous years, we've had a little bit of variation, but this year they've made it very specific that you want to use the pull of a string in any manner. So the exact pulling, how that's going to work, what it's going to trigger is up to you, but you must pull a string. All actions must occur within 90 seconds of the initiation of the machine. And a key thing to know is that your vehicle's motion is not a part of that time. So you can take all the way till 90 seconds for your fan to start working, or your fan to just, push the vehicle, and the vehicle can go as far as it will until it stops, and that's not included in those 90 seconds. So like, in other words, it's not like you have to finish everything in 60 seconds and that vehicle only gets 30 seconds to move. It will, when it moves, that's its own time and it's not being timed. So as you can see in the right corner, we have like another example of a vehicle with paper, simple things. And so the specifications on the vehicle is that it cannot be connected to or touching the actual MESA machine, which in this slide is called the device. So MESA machine, device, Rube Goldberg machine, those are all interchangeable. They mean the same thing. It can only be powered by wind energy, which is why I said that most likely you're going to be using a fan, hair dryer, something of that sort. And we're actually working on right now helping you guys define what that final action should be or can be. It must have 2 or more axles. So like this vehicle on the right, we have 2 axles. And then going just generally to any of the actions for the simple machines or electronics, sequential and dependent actions must use a different category of simple machines / energy to count as another action. So when we're counting 1, 2, 3, 4, 5 of your actions, you can't have an inclined plane going to another inclined plane, so a ramp to another ramp. That will be only one action. But if you have a ramp going to a pulley, that will be 2 different actions. The first action is the ball rolling down the ramp, and the second action is the ball falling into the pulley and triggering whatever else. So those are 2 actions. If you have 2 ramps next to each other, that's only 1. So keep that in mind when you're creating your design. And some small notes on the bottom, that after initiation, there's no human interaction allowed with the device. So if your machine malfunctions somewhere, that's you cannot push the little thing that's in the way. You're just gonna have to let it be. And if you use, so in previous years, we've had pressurized fluids. And most of the time people have used, one time somebody used Mentos and soda. So that counted as a pressurized fluid. And I've seen balloons. I've used balloons too. So those 2 things have counted as pressurized fluids, and you can't use those this year. They will not count as a simple machine or an electronic because they don't fall under those definitions. So for middle school, one of the biggest things, the differentiation between middle school and high school is going to be the size. So with middle school, your MESA machine's maximum size is 75 centimeters by 75 centimeters by 75 centimeters. So like a big box. And your wind-powered vehicle maximum size is 35 centimeters by 35 centimeters. There's no height requirement, but as you're gonna see in a later slide, there is a there's diagrams of how big things can be, and so your vehicle has to fit in that box. And on competition day, they're also going to make you put your MESA machine or your vehicle inside of these taped boxes, and when it sticks out, that will be a disqualification. So like I was saying before, really important that you label properly, because if you don't, you lose 10% of your total score. And that's going to be extremely imperative in this competition because of the chaos that it deals with. So teams may repair or modify their machines in between trials. We have 2 trials, and if you, for some reason, are disqualified in the first trial, you just take a missed trial, you have no score, and then you can fix up your machine if possible, and then participate in the next trial. And so this is why things like the size, it's very important to keep track of right now, because if you make a wooden frame that's 80 centimeters by 75, it's going to be hard to take off those 5 centimeters on competition day, because it is like a wooden frame that you needed a saw for example. So each team's given 2 minutes to prepare the machine. ready the wind-powered vehicle, and verify to the judges the 6 to 12 actions. So what that means is if there's 3 of you, one person is putting all the marbles in place, one person is setting up the vehicle if it needs any adjustments, and the other person is telling the judge, this is what we have, this is what we have. So that's kind of how that goes. And then a few other notes on the bottom there. The complex machine must have moving parts at all times. So we need to see those parts where we don't want like big tunnels where there's intricate actions going on inside, but we can't see it. So if you're going to have an electronic piece inside of like a PVC pipe, we need to see that there's that electronic component. So the best thing about this project is that everything is fair game. You can use any materials except hazardous materials or materials that in combination will create an unsafe energy, like something exploding or that will like leave shrapnel and debris everywhere. We don't want to use those things. That's a safety risk. But otherwise, the world is your oyster, and I can't wait to see all the pearls on competition day. So for middle school, your judging, the judging goes, it's a distance thing, and this is different for high school. So for middle school, your objective is that your wind powered vehicle needs to go the farthest that it can go, and not to get too much into all the numbers on the right. So just make sure that you check out the rules. But the biggest thing you want to understand about the judging is that it's the team score is the culmination of the machine points, the accuracy points, and the time points. And so machine points means for each of your actions that works, you will get 6 points. And then for accuracy points, where it lands in those distance zones, you get a certain number. And then your time points, how long does your MESA machine take to finally start pushing the vehicle? So actually in this year, it seems, oh no, actually, yeah, it seems like this year, the faster it is, the more points you're getting. So I'm actually going to double check on that. But yeah, that's what we have here. This is from the rules. And the best team score of the 2 trials will be used. So you get 2 trials and we use the best one. So for high school, we get a smaller box. There's a picture of mine from 2 years ago. It's pretty much like a tiny stool in comparison to the 75, to the middle school box. But so we have your MESA machine at its largest can be 50 centimeters by 50 centimeters by 50 centimeters. And your wind power vehicle's size is 25 centimeters by 25 centimeters. Again, there's no height maximum. Same rules apply on labeling, same rules apply on how much time you're given to prepare the machine, and being able to repair or modify your machine. So what that means is that on competition day, along with your MESA machine, along with your vehicle, you're gonna want to bring a repair kit of some kind with important things. We don't really have hot glue gun stations. I think last year we were lucky to be in a room that had an outlet, but just as a tip, try not to have things that you might want to patch up or things that might need patching up with hot glue because you might not have access to that. And then the same rules kind of apply. We have to see all your moving parts. We don't want any hazardous materials or anything unsafe. And on competition day, we have a target. And yeah, so the target is identified as a dot. It's going to be a certain amount of range away, and we want to get like as accurate like on there as possible. In previous years, we've had kind of like a circle. They've drawn like a circle target for us, and we land in areas close to that. So here's kind of similar. We want to land on the dot or close to the dot, so not as far as possible. And again, here, best team score of the 2 trials will be used, and there's slightly different numbers on the on here. And so we have the team score equals the machine points, the accuracy points, and the time points. And And so now it's time to get started, now that we know kind of the rules, and we are going to double check the rules at the end of this for middle school. So I have some tips and tricks from my 4 years here. And first of all, read the rules. I cannot emphasize enough that you should spend like just one working day sitting with the 12-page rules and highlighting, annotating, brainstorming, understanding what those terms are, understanding what all of those simple machines are, because some of them are kind of complicated, despite being simple. Ask questions like, what can I use XYZ for, or how can I use this? You really don't need to go out of your way and buy like PVC pipes and drills and screws all the time. This project is really, it can be like really sustainable, and you can use things around your house and use recyclable goods. So for my example was, how many ways can a roll of tape be used? We can use it as a wheel, a structural support, a ball, a weight. You think of all like the physical properties of anything, and you can actually make a lot out of it. If going back to kind of my first picture, I used old Pokemon cards to make ramps by gluing them together. So be innovative, try new things, and that's what all this project is all about. Use your resources, learn new things, and experiment with them. So kind of what I just said, this is like a very experimenting project. And by using your resources, not only gain inspiration from kind of like viewing things in a different way, but also just like concrete resources that we have right now. The Pacific-Mesa.com website has a lot on there already for MESA Machine, and I compiled a bunch of resources, if you scroll to the bottom, that is hopefully of use to anybody doing this project. And I have like some cool videos and things that I really like on there too, that have given me inspiration about engineering and like paths you might want to pursue. So if you check that out and you like it, it'll put a smile on my face. So then simulate competition day. So make your own judging area and test out your own machine. So what that means is you're going to want to, you know, get the measuring tape out and measure out the 2 meters or the distance zones, and make sure that you can try to like replicate that judging area, and then set your machine down. Constantly make sure that it's within the qualifications, because with any of your projects, really, some things can shift on there, like due to the hot glue or whatever, something coming loose. So you're going to want to constantly check that you're within those measurements and that things are going right. So test and test and test again. Keep on testing, test after every action, every few actions. So with that being said, it does sound like there's a lot of work with this project. And to be entirely honest, it is a time commitment, and it can be challenging, but with challenge also comes the fun and the learning experience. So I've learned so much through this project, and for anybody interested in this project but maybe getting scared by it's so broad, I have an objective but I don't know what to make inside the machine, this is like a great chance for you to kind of come out of your shell and experiment and innovate during this pandemic time, where you might have a little more time to do other things and really try and figure out, you know, what you can do with this. So some of my tricks are a classic aid: to use pieces of tape, paper, or cards to add curves in an otherwise straight path. So if you made the box that you saw in the high school edition of the slides, then if you just put like little pieces of cards, you can bend them and the marble will just follow that curve. So that way you don't have to you're not stuck anywhere with your ramps. You can curve everything around. And then can't think of an action, try to model one of your older actions in a new way. So you can use a ramp in the beginning and use a ramp later as your 6th action. But we don't want to see 5 different types of ramps, but try to make a ramp out of wood and then make a ramp out of like cloth or something. Or, you know, I'm not going to give too many ideas here because I want you to experiment, but how many materials could serve as an inclined plane, which is also like another way of saying ramp, or well, a ramp is an example of an inclined plane. So you know, try it out, experiment. And then the biggest thing, which gets everybody on competition day, be careful of wobbly platforms, hot glue strings, gritty surfaces, etc. This is all like that chaos, that word I've been talking about, chaos, like chaotic moments. That's one of the challenges with MESA Machine is putting those actions together. And so, yeah, with that being said, here are more resources that I've been talking about. So we have our main website, and I kind of like showed how to get to all of our stuff. If you have questions, there's the contact, and then 2 questions I just want to go over briefly. Are magnets allowed, and can they be used as actions? So magnets are not a simple machine. They're not counted as an electronic either. They can be in your MESA machine. So here's one of the key things. You can put whatever you want in your MESA machine, but if it doesn't count as an action, if you want to add up to a certain number of actions, this will not work, but you can have this in addition. But like looking at our example, if a magnet rolls down an inclined plane, the inclined plane is the action, but not the magnet. So you can technically like try out magnetic interactions and things, but those themselves will not count if you're really stressed about making that action limit. So are balloons allowed and can they be used? Like I said before, they're a pressurized fluid. They're not allowed to be used, but they can be used in conjunction with a simple machine. So I know I had a lot to say. So are there any questions?
Yeah, so there's a few questions in the chat. We're slightly over time, so I'm just going to summarize Rose's answers there. First of all, in terms of the time points for middle school, it is the faster you get through your machine, the more points you get. And high school, it's the closer to the time goal of 120 seconds, the more points you get. So it's kind of opposite in high school and middle school. A clarification about the actions. If you have one inclined plane and then separate it with another type of action like a pulley, can you then use a ramp again? The answer is yes, as long as they're separated, that will count as three actions, just as long as they're separated by a different type of action in the middle. Reason why we're not launching a ball this year, in the past it was a ball, is because statewide MESA just likes to switch it up, make it different type of challenge. And so it's launching a vehicle this year. And we got a bunch of other questions that are coming in. Wow. Okay, so I'll have you answer those questions, Imran. Okay, let's see. So we're required to do these projects. Okay. Awesome.
Okay, so yeah, Rose.
The first one is from Alexi. The first one that I didn't answer is from Alexi saying, is it possible for a high school student to team up with a middle school student? I'm actually going to answer that one. I mean, technically you could work together on it, but when it comes to competition, they're separate. So there's not really a way that we would be able to award both of you, considering you would fall into different categories, if that makes sense.
So usually what we would do is we would have, so for example, if we have a 12th grader working with a 9th grader, because 12th, 11th is a different category than a 9th, 10th, we would put you guys both in the 12th grade category. So I would say it would be the same if you were like a 7th, 8th grader working with a 12th grader, then you would still have to go into the higher ranking.
Okay. And then Miss Sadie had a question. What if the balloon popping causes something to move? If that could count as an action? And that's actually a very good question that I don't know the answer to. So I'm gonna check in with the workbook sponsor on that one and see what his answer is. So I've taken note of that, and then I'll get the answer to that and let you know as soon as he gets back to me.
I think though, without that clarification, the something moving, if it's a simple machine of some kind, or interacting with the simple machine, I think that will count, but the balloon popping itself will not count.
Yeah, that makes sense to me.
That makes sense, yeah.
Yeah, and then just to reiterate, like the simple machine and electronic in one question, can you do a simple machine and electronic in one? So a simple machine will be one action and the electronic will be another action. Or to break down the simple machine categories more, if you have an inclined plane and then a wheel and axle, those are two different types of simple machines, but they're going to be counted as two different actions because they are like let's say we did electronics and we had a DC motor and then a sensor. Those are going to be two different, like some actions with those are going to be two separate actions. So you can do simple machine if they're two different simple machines, or simple machine and electronic, whatever combination, so long as it's not like the same thing twice.
All right, I think that covers all our questions in the chat. Anybody have anything else? All right, well, we're already over time a little bit, so we'll wrap it up. But thank you so much, Rose and Nimran, for a great presentation today. And thank you guys all so much for joining us. I'll have these recordings posted and everything else on the website, pacific-mesa.com. Check it out. We got all kinds of resources there. And have a great day, everybody.
And an awesome weekend.
And an awesome weekend.
Bye, everyone.
Bye.